Hello friends, welcome back to the channel Maths with Berlin. So this is the future JEE advanced question series, and here we discuss various relevant JEE advanced questions. So if you see, for today we have the following question that tells us that let k denote the number of solutions to the equation cos of x equal to sine of sine x, right, for x belongs to 0 to 69 of pi. So this is basically this is the solution set that we have got, right, and we try to figure it out. So basically, if you all know, right, that the trigonometric solutions are basically multiplicative or recursive in 0 to 2 pi, then from 2 pi to 4 pi, and so on, right? It is like this, it goes on like this. If you can find the number of solutions in 0 to 2 pi, you can find this number of solutions in all, right? So what we do is we take x belongs to 0 to 2 pi for our case, right, to just simplify the solution. So in basically, when you take the value of x as in between 0 to 2 pi, what happens is when x is negative, let's say the value of, no, wait a minute, let's say the value of x belongs to 0 to 2 pi, and wait a minute, let it belong to 0 to pi by 2 first of all, right? We try to make it in intervals. So when it belongs to 0 to pi by 2, what happens is this term right here is positive, this term right here is also positive, and therefore it can give a solution in between 0 to pi by 2. Now focusing on pi by 2 to 2 pi, but not pi by 2 to 2 pi, it's pi by 2 to pi. Focusing on the number of solutions between pi by 2 to pi, what you get is this solution, right, this expression right here that is there. What happens is this expression becomes a positive quantity, and this expression right here is always a positive quantity, so it can give a solution. It can, I'm not saying it will, but it can give a solution. But if you see from pi to 2 pi, right, from pi to 2 pi, if you see, this expression is a negative quantity, also this expression is also a negative quantity, so it cannot give it, right, it cannot give a solution. So we cannot include pi to 2 pi in the solution case. So therefore what happens is when you take the, actually I have proved it in like this, that if you take the value of x belongs to 0 to pi, then what happens is minus x belongs to minus pi to 0, right? So basically you can write this as x belongs to pi to 2 pi for this one, right? These are interrelated to same expression. Now what happens is when you take x is between 0 to pi, this expression right here becomes positive, this expression is positive, and then positive plus positive can never be equal to 0, right? So that is what we have done here. After that, what we can do is we can just try checking out that if it is symmetric or not, right? We try to check out that the expression is symmetric or not. So when we put f of x and f of pi minus x, it becomes equal. So therefore the expression is symmetric about pi by 2, right? It is symmetric about pi by 2. Now what we do is we got the maximum value of sine x plus cos x in between 0 to pi by 2 as root 2, but that is less than pi by 2. So you may take the maximum value as equal to pi by less than pi by 2. After that, what you do is you take the cos x to the right hand side, and then take a sine of x on both sides, right? You can take a sine of x, the inequality doesn't change as the value of sine x is between 0 to 1, right? Now when you do that, what happens is you get the value of the inequality as sine of that function and cos of the function can never be equal. It is always, the cos function is always greater than the sine function, so therefore we get that it has no solution, so therefore k equal to 0, right? So that's it for today. Thank you everyone, have a nice day.